How's it going, everybody? In this next video, we're going to go ahead and migrate to a slightly different setup where we're going to be focusing on the point-to-point pseudo wires that we've been discussing and breaking down so far, except for now we're going to change up the configuration. Instead of doing Xconnects underneath the physical interface or going underneath the sub-interface or looking at bridge domains, we're going to look at using L2VPN Xconnect connectivity in order to provide connectivity between R1 and R3 respectively. And then we're going to slowly scale that up. So let me go ahead and break down exactly how this is going to work and why is this important. So let me go ahead and pull up my pen tool because at the moment I don't have it ready to go. Go ahead and do that real quick. Not too many things on the screen, and there it is. Going to make it a whole lot easier to whiteboard it. So the idea that we want to obtain is we want to be able to set up a connection. Whoops, I need to make this, let's go medium. We're going to set up a connection from CSR1 to CSR3, right? So it's not a huge pseudo wire, but it still needs to be deployed. Now the objective and the idea of what we're trying to accomplish here is getting connectivity from R1 on gig 0/0 to R3 on gig 2, but on a per VLAN basis. So there are ways you could do it at the interface level, service instance 1 Ethernet and encapsulation default, stuff like that at the main interface config. And then on this side here, you configure you put the config at the main interface, at the main interface level. So gig 2, and then you apply the IP address there. You don't do a sub-interface. Now, what we're going to be doing is we're going to be leveraging the L2VPN CLI variation. So CLI. And what this basically does is when you have the service instance applied, so at the interface level, you're going to create the service instance. So a service instance, and for example, I'll call this 10, and we'll call it Ethernet because you need to define that. Then we'll specify the encapsulation. The encap will be .1Q and then 10. So it'll listen for any traffic coming in as an 802.1Q frame. What we'll do underneath the L2VPN connection is we'll specify a member and the neighbor. The neighbor config is going to be, some address, XXXXX. Then you'll have to specify a VC ID. So, for example, we use a virtual circuit ID of 10 because we're using VLAN 10, service instance 10, etc. And then we're going to have to specify the encap of MPLS so that it knows how to actually encapsulate the traffic. The next step we need to do is call the member, another member config, and we're going to specify the interface. So in this case here on CSR1, it'll be gig 3, and then we'll say service instance 10. And that's basically going to allow the communication to happen. I still have the debug running on CSR3, so we'll still be able to see the operations and stuff like that come into play. That's essentially what we're going to go do. So let's go ahead and get the config rolling here. So the idea, I actually just deleted it so that we could go through a new implementation together. So we're going to go to CSR1. And the config is actually very, very straightforward. So let's go to interface gig 3. We're going to type in service instance, and we're going to say 10 and then Ethernet. And then underneath here, we can do a number of different things. The first thing I'm going to type in here is encapsulation will be .1Q and then 10. That's all I had to specify. Now, I'm going to go up to the L2VPN. There's a couple of different variations for it. We have the Xconnect. The Xconnect is what we're going to be using because we basically want to set up a point-to-point connection between R1 and R3, CSR1 and CSR3 to allow R1 and R3 to communicate with one another. So I'm going to type in Xconnect and then the context, and then I'm going to give it a name. I'm going to call this VLAN 10 underscore neighbor. The reason why I'm specifying neighbor is because when I go to configure the connection, I'm going to call member neighbor, not member pseudowire. So I can add more capabilities and functionality if I use the pseudowire config. So create the pseudowire ahead of time, add whatever advanced capabilities like advanced pseudowire features, control words, signaling, sequencing, all that type of stuff. That'll be coming in upcoming topics, because once we nail it down from a point-to-point connection, it'll just be that much easier to understand it later on when we get into things like VPLS, both the manual and the auto discovery, HVPLS, PBB, EVPN, etc. So I'm going to do that, and then underneath here I need to specify the member. I'll type in the member, and the IP address is going to be 10.0.0.3, and then I'll specify the VC ID is going to be 10, and then the encapsulation will be MPLS. Simple as that. Now, in order for this to kick off, I need to actually type in exit for it to begin doing its thing. So on CSR3, we're going to do the same thing. So interface gig 6, type in service instance 10 Ethernet, encapsulation .1Q 10, and then we're going to type in L2VPN Xconnect context is going to be VLAN 10 underscore neighbor. And then we're typing member is going to be 10.0.0.1 with the VC ID of 10. The encapsulation is MPLS. Okay. So that goes ahead and it adds a new member pseudowire, which is exactly what you want. So that's the added pseudowire member. We're going to type in member and then the gigabit 6 and then service instance 10. Okay. Now nothing's going to happen until I exit out, right? So the internal database has been provisioned. Now we need to go ahead and exit out, and that's going to allow the provisioning to actually take place. And then you see all this data going back and forth, trying to figure out what's happening and all that type of stuff. So we see the pseudowire status is up. It's Ethernet VLAN. The segment type is Ethernet or VLAN, so we know that. The VLAN ID is 10. The interface string is 16 or gig 6. The current circuit string is 10. So everything looks good, right? So we go back over to CSR1. And we come out here and we do a show MPLS L2 transport VC, and right now it doesn't show up. So we have to double check our config. Let's make sure that I haven't made any mistakes. I did. So let's go to L2VPN. Let's just copy and paste this in. So I've gone through and I've set up the pseudowire, but I didn't call the interface, so I haven't tied it together. So member. In this case, here would be gig 3 service instance 10. Okay, now I'll go ahead and I'll exit out, and then that will change. The pseudowire is now up, and we are in good shape. So we see that information going back and forth. We'll give that a couple seconds to do its thing, and now the VC ID is up. So we're going to come up here and do this command right here, the show MPLS L2 transport VC, and voila, there we are. Now if I hit the up arrow and go detail, we're going to see a lot of information. So we can see that the local and the remote VC labels is 45. If we do a show MPLS forwarding table, and we come down here at the bottom, we can see label 46 is being used, which if we scroll back up here to the top, we can see the local is 46, right? Which is a good thing. So, and you can also see that the things like the control word is on, it's auto-sensed, sequencing is disabled, stuff like that. We're going to take a look at that more in detail later. I'm actually going to go into, once we do this config and then we do, we're going to add in high availability. So we're going to throw in a group, which we did not cover. And we're not going to do it in this video, we'll do it in another one. But we'll go in and we'll set up a high availability through a group switchover, and we'll set a priority and stuff like that. But for right now, this is where we're going to stake our claim. So we have that. So that's all working. So now I'm going to go back over here to R1, and I'm going to go ahead and do a show IP interface brief. And I'm going to go ahead and I'm going to ping 10.1.3.3. And I'm going to ping. And you can see the ping goes through right away. If we do a show ARP, we can see that the ping is, the MAC address is propagated. If we go to CSR1 and we do a show bridge dash domain, there is no bridge domain, right? So the bridge domain does not apply here because of the fact that we're not using a bridge domain. Not yet anyway. So let me just take a moment and explain why we don't need a bridge domain. Right now, we're not trying to take connectivity from two or more other connections. So the bridge domain is basically going to act as the VLAN or the database where MAC addresses are going to get populated as they are learned in from the Ethernet flow point or the attachment circuit here. And you're also going to learn MAC addresses over the pseudowire connections. So for example, CSR1, let me go ahead and move this out of the way. CSR1 might have a pseudowire connected to CSR7. And CSR7 might have a connection down to CSR5. And if CSR1 and CSR5 are communicating with each, I'm sorry, CSR or router 1 and router 5 are communicating with one another. What will end up happening is the pseudowire set between CSR1 and CSR7 will learn those MAC addresses inbound on those attachment circuits, and then that information will be injected into the bridge domain. And since there are pseudowires that are going bi-directionally back and forth, those MAC addresses will be propagated across the pseudowires to the remote PE routers that are running the bridge domains, and that will allow router 1 to learn router 5's MAC address. So when we get into dynamic routing, we're actually going to set it up to where once we get the VPLS config in play and stuff like that operational, you'll see this stuff start to pop up. So I'm going to be showing you two different variations of the VPLS. It'll be the L2VPN and then the older bridge domain underneath the service instance config and stuff like that. But that's basically how this comes into play. So this is really basic, right? If we look at this, we do a show, whoops. If we do a show MPLS L2 transport VC, we can see there's an active connection, right? If we do a show Xconnect context or Xconnect all, we see that there's an active Xconnect. So you might say, well, why would you look at the Xconnect config? Why do you look at MPLS layer 2 transport? Why? What difference does it make? Well, the reason why I do, do this one here for the detail is this one doesn't give me as much detail as the other one does. This one will tell me my local VC label. This one will tell me my remote VC label. So essentially, it does give me enough base information to make some decisions off of, but this one right here gives me a lot more information. It tells me what's going on in a lot more detail. That's okay though. I don't really need it per se, but it does work the way that I want it to. So what we're going to go do is we're going to take a look at this a little bit. This video is pretty much done, right? I just wanted to show you how that would come into play. What I'm going to do in a upcoming video is we're going to flip over to this to a neighbor group. Actually, you know what? Let's just do it right now since we're right here. So I'm going to go ahead and jump out of the way. And what we're going to do is we're going to set up a second connection, but with a different VC ID, and we're going to put it into a group. So I'm going to start on, we'll do it on router. So what this basically is going to do is it's going to be a second connection in the backbone. So it's not going to be a second pseudo wire or attachment circuit. So this is just going to be redundancy inside of another pseudo wire in the event that the first one goes down because of whatever happens. So this will be pseudo wire redundancy. This won't be attachment circuit redundancy. So the way that I'm going to do this is do show run section L2VPN, and you'll see that the config is set up the way that it is. So if I come up here and I type in this command right here, I type in member 10.0.0.3, and I come in here and I specify another value, so I'll put in 101, and then I'll type in encapsulation is MPLS, and then I say the group, and I type in, we'll say neighbor group for 101, and we'll set the priority value to be 101, right? Because I don't think there's a, we'll put this one to be 11, right? It says invalid, member has invalid member group. So what this basically means is, actually let me do this. We'll type in group, and we'll specify priority, or I'm sorry, group, and we'll hit the enter key. And so what's happening here is it's an out of order configuration. So the order of operations has been improperly configured. So I'm actually going to go do show run section L2VPN, and I'm going to go ahead and delete this because we actually have to delete the config when we go do this. That's going to take the VC down on router 3. So what I'll do is I'll type in member 10.0.0.3, and then we'll type in 10 encapsulation is MPLS, and we'll specify group and the group name, and we'll specify the priority of 10, right? And then we're going to come in here and we'll do 11, for example, go to the end, and we'll put that in there. So you have to add them at the same time. So do show run section L2VPN, and now we've added a group, right? Now they're grouped together in this, and it's priority 10, so the VCID 10 should come into play, right? And so I'm going to go do the same thing over on router 3. So I'm going to exit out here, and we're going to go to CSR 3. We can see that it came up, and if we look at CSR 3, once he's done doing his config, we'll do a show run section L2VPN, and we'll see the same thing. So we're going to come underneath here. I'm going to go and remove this command here, type in no, pull that out, and then give that a couple seconds to figure itself out. And what I'm going to do now is I'm going to type in, hit the up arrow, pull this command out, go to the end, and type in group, and then the priority is going to be 10, and this one will be 11. Actually, hold on, let me do this real quick. And this will be 11, and this will be 11. So that adds it, and you can see that there's two different 4002 and 4004. I'm going to go ahead and exit out, and you can see that information what you'll see is, okay, so I'm actually glad it showed that. I'm glad I had the debug running so you guys can see the behind the scenes. So one will be up while the other one's in standby. So we'll look at CSR1. We can see that one's up now too. So let's go down here. We'll type in show MPLS L2 transport VC. And you'll have one that is up and running and one that is in standby. So it's a secondary connection. This is, again, pseudowire redundancy. So in the event that you tie a pseudowire to MPLS traffic engineering, for example, and let's say you tie this one to MPLS TE and you tie up to a preferred path with a template, which you can do. We'll talk about that here in another video. But the idea is when you do it this way, there's you're providing high availability, but the way that you would do this is the gig 3, the standby, you would tie the config together so that in the event that the first pseudowire, so VCID 10 went down because of some issue, you'd have MPLS traffic engineering like fast reroute come into play, and then the other VCID would take a different path through the MPLS backbone to the remote PE. Really no different than you would do with MPLS TE in layer 3 VPN. But here in layer 2 VPN, because you don't see the actual trace route, you don't see the hops, that's basically how it comes into play. That's basically what you need to understand. So with that being said, if we were to do a show, let's do this and do detail, you would actually see two different levels. But if we look at this top one, this is the primary. We can see 16 and 47. And we can see that from a LRU, RRU, local running and up, remote running and up. Down here on this one, we are local running and down, remote running and down. So both sides of the connection are down. They've allocated labels, right? If we do a show MPLS forwarding table, we can see that we have two circuit IDs. This one here is our primary. This is VCID 10, and this guy here is VCID 11, but it's none. So what would end up happening is you would need to fail over to the other VCID. There is a way to do that, and it is L2VPN redundancy activate peer 10.0.0.3, and then you would specify 11. So for whatever reason it fails. Let's see if it'll give me a reason why on this guy. So it's L2VPN redundancy activate. I will type in peer 10.0.0.1 and then 11. Okay. Manual switchover failed. Cannot process switchover request. That might be because of the fact that I don't have redundancy enabled. But I know you can switch over between the two. So if you needed to do maintenance or something like that, or make some changes, you could fail over to take a different path through the backbone. So that's one way. We'll come back to this. I'll test this out offline and see if that makes a difference. But we will be taking a look at redundancy here and another version of redundancy. This is just showing you how to configure two different pseudo wires in a group so that you have standby. And so you might be wondering, well, why would that really matter? Why would you need to have one as active, one as standby? And the main reason for that is actually very simple. When you have a situation where you got a peering to another PE router for a attachment circuit, and you've got two pseudo wires configured, you can have more, right? You can have, like, I think the most I've ever configured is 5 or 6. So only one can be active at any one point in time. And the logic falls back to those of you that understand how spanning tree protocol works instead of a layer 2 environment. So I don't see my thing showing up here. Let me go ahead and close out of this. Oh, it crashed. Let me go ahead and explain to you basically what's happening here. So go ahead and get out of the way. So the concept is actually very simple. Let's take a pair of switches. Actually, let me go bump this up to medium. So you take a pair of switches, right? And you run parallel connections, right? Spanning tree protocol is going to block one of these ports so that you're not sending traffic across both ports at the same time, because Ethernet is a flood and learn. So if something happens, a broadcast is sent out here, it's learned in here, it's potentially sent back out here, and then learned in back in here, and then it goes back out here, and then you get into a looping scenario, right? That's a bad thing. Well, what ends up happening instead is the same thing here. So we have a router here, and we have a router here. We're running one pseudo wire here, and we're running one pseudo wire here. This one is active, this one is standby. The reason why this is standby is because the forwarding and the MAC propagation is done in the data plane. So this line or this wire here for the pseudo wire, this is the pseudo wire. All of that happens inside of the data plane. So that happens with point-to-point connectivity, whether I use the neighbor command, whether I use interface pseudo wire, whether I use a template, whatever the case might be. VPLS, HVPLS, they all leverage data plane learning and data plane control. Data plane propagation happens in the on the same wire that you would send the. So I'm sorry. Let me rewind that. Unlike BGP, where you would propagate a prefix and then you let the underlay figure out how to get it there, here the pseudo wire is both the control plane and the data plane at the same time. Where spanning tree protocol comes into play, and spanning tree protocol or STP will block a port, and that means that port cannot be used to forward traffic out of. That's going to dictate how you forward traffic out of a particular interface. The same concept applies here. The difference is spanning tree protocol isn't used inside of the MPLS backbone with pseudo wires. We leverage the split horizon capability instead. So split horizon comes into play and is enabled on this interface saying, okay, you can't do this. So as a matter of fact, if I was to go ahead and clear the screen and look back at this guy, and we were to look at show MPLS or L2 transport and VC. Let's see. No, it's not what I'm looking for. Show Xconnect. No, so it's show L2VPN VFI. We would see split horizon enabled. Show L2VPN Atom VC. And is there a detail option? There is. This is basically the same look and feel. Oh, this gives me slightly different outputs. But what I'm looking for, this is what I was looking for before. The BC, the CV type. This is what I was looking for before. I'm not seeing it jump out at me at the moment. but basically what's happening is split horizon is enabled on one of those interfaces, on one of those pseudowires. So it's not allowing the traffic to go out, because if in the event that something goes out one interface and comes back in another, you don't want that to happen. So because the priority is higher on VCID 11, you need a bound that's going to prevent that pseudowire from coming up. So I don't know if I can go in and change the redundancy. Let me just double check that real quick. So let's go up here and grab this, and then we're going to type in redundancy, delay, let's see, we'll give it 10. So redundancy predictive enabled. So I don't know if that needs to be on both sides, but the idea is we don't really have a way of polarizing or testing this. It's a little easier when you tie a pseudo wire to an attachment circuit, and the attachment circuit goes down, and you can fail over. But we don't really have that set up right now, so I can't really test it. But I'm gonna look into this. I'll figure that out, because I would like to switch over, or just to prove that it does work. But I'll test this out offline. But that's basically the logic that comes into play. So the idea would be to be able to switch over from one label switch path to another label switch path in the event that there's a problem inside the backbone, and you would tie your higher priority pseudo wire, the one that you want to be the backup, you would tie that to an MPLS traffic engineering tunnel that would take a different path through the backbone. In the event the primary path went down, you would do fast reroute on the back one, or the backup tunnel, or the backup pseudo wire, so that the primary went down, the backup would take over, and it would use a different path through the MPLS backbone to keep your customers online. That's basically the logic to it. And you would use the preferred path underneath the interface pseudo wire. We're going to talk about interface pseudo wires coming up here in the next several videos, because we're pretty much done with the neighbors. There's really not a whole lot to talk about that, because you get way more functionality when you go the pseudo wire or interface pseudo wire config, manually configure, instead of it being dynamically created. So we'll talk about that more in the next several videos and get through all that. Till next time, guys, take it easy. I'll catch you in the next one.